I will begin today's electronic project with a touch button. This small sensor will allow us to control the entire circuit just with a gentle touch instead of a traditional mechanical switch. To start, I solder two copper wires to its pins so I can easily connect it with the rest of the components. Next, I carefully apply a thin layer of solder on both copper wires to ensure strong joints and reliable conductivity. Then, I take a BC547 transistor, which will act as the main switching device in this circuit. I solder its emitter and collector pins directly to the copper wires, creating a solid foundation for the rest of the design. Now, to control the transistor properly, I need a resistor at the base. I solder a 2.2 k ohm resistor between the base pin of the transistor and one of the copper wires connected to the touch button. This resistor ensures that the transistor does not get overloaded with current. After trimming the extra pins for a neat look, I add a new copper wire directly to the base pin of the transistor to connect upcoming components. It's time to bring in the LED. I start with a 3-volt LED, soldering its negative pin to the copper wire that is connected to the collector of the transistor. This way, whenever the transistor switches on, the LED will light up. To make the project even smarter, I bring in an LDR, light-dependent resistor. I solder one end of a copper wire to the remaining pin of the LDR and the other end to the positive pin of the LED. This clever step allows the circuit to respond to changes in light. When the LDR senses darkness or when something blocks the light, the LED reacts. Now it's the time to power up the project. I connect a 3.7-volt battery to the circuit, positive wire goes to the copper wire connected to the positive pin of the LED, and the negative wire goes to the copper wire connected to the emitter pin of the transistor. With power applied, the circuit is complete and ready for testing. But wait, during my first test, I noticed that the circuit was too sensitive to light in my workspace. Even small changes in brightness were triggering the LED. To fix this, I replaced the 2.2 k ohm resistor with a 1 k ohm resistor, which reduced the sensitivity and made the circuit more stable. Now comes the exciting part, testing the circuit. When I gently press the touch button, the LED immediately turns on, giving instant feedback. But as soon as I bring an obstacle between the LED and the LDR, the LED turns off. This proves that the system is working perfectly as both a touch-controlled switch and a light-responsive detector. So, how does it work? The touch button activates the transistor, which powers the LED. At the same time, the LED light is constantly shining on the LDR. When the LDR detects this light, it keeps the circuit stable. But when something blocks the light, the LDR's resistance changes and the circuit cuts off the LED. Where can we use it? This circuit can be used in automatic lamps, smart lighting systems, burglar alarms, hand detection systems, or even interactive DIY projects. Imagine creating a lamp that you can switch on by touching it and switch off just by waving your hand in front of it. This circuit does exactly that.